Hello, everyone. Today, we will be discussing our project on early stage diabetes risk prediction. First, we're going to look at, in a short introduction, the problem identification, the data processing, data visualization, and finally, conclusion. So to start off with a short introduction and our identified problem. So for the purpose of this project, the dataset we are using is titled Anticipating Diabetes Onset Early Stage Risk Prediction Dataset, created by Kaggle Expert ZJ in 2024. This dataset is particularly valuable as it contains crucial information about individuals who either exhibit early signs of diabetes or are at risk of developing it. The dataset includes both demographic details, such as age and gender, and specific symptoms that are commonly associated with diabetes, like excessive first and sudden weight loss. It provides a structured collection of data where each row represents an individual and each column represents a specific attribute. The dataset serves as an important resource for researchers and healthcare professionals as it can help in developing predictive models for assessing early stage diabetes risk. By analyzing symptom patterns and their relationships with demographic factors, we can gain insights that contribute to the advancement of early detection and intervention strategies in healthcare. Our study's objectives are to analyze the age, gender, and symptom patterns, to identify risk factors for early stage diabetes, and to provide insights for early intervention. With that in mind, our central research question is, how do age, gender, and symptom co-occurrence influence the likelihood of early stage diabetes risk? Throughout this project, we will explore data visualizations and analytical insights to address this question and identify meaningful patterns in the dataset. Now, let's move on to the next section where we will dive deeper into data processing and our chosen variables.
Out of the variables available, we decided to focus on age, gender, symptoms co-occurrence, and association of age and number of symptoms. Regarding age, we decided to compare the distribution of people at different ages who are at risk of diabetes with those at different age who are at no risk of diabetes. It is concluded whether age is a factor affecting the cause of diabetes. So age distribution map will be shown in a histogram as it goes forward. We also decided to check the relationship between gender and diabetes risk and analyze the distribution of diabetes risk among different people of different genders. Degree of association. We decided to talk about how age and the number of symptoms causes risk of early stages of diabetes, and also to talk about the symptoms that occurs in an individual as they start to experience early stages of diabetes. And lastly, symptoms co-occurrence and the consistency of symptoms that appear in the person who is at risk.
Okay, so it is important to highlight the steps we took to clean the dataset, and the goal of this process was to ensure the data was consistent, accurate, while being reliable for our analysis. First, we performed exploratory data analysis, EDA, to check the dataset structure, to detect missing variables and identify inconsistencies. Next, we standardized the data by renaming columns, replacing spaces with underscores and converting them to lowercase to ensure everything was uniform and in order. We also ensured categorical values such as yes and no were consistent by converting them all to lowercase. And finally, we checked for duplicate records and found 269 duplicate rows. These were removed, reducing the dataset from 520 to 251 unique records. This step was crucial to prevent redundant or misleading insights in our analysis. So this slide kind of shows the results and key takeaways of our data cleaning process. Before cleaning, as you can see, the dataset contained inconsistent column names, variations in the categorical values, and duplicate entries. These issues could lead to errors in data analysis and model training. After cleaning, the data set at the bottom there is now in a standardized format with consistent naming conventions, properly formatted categorical values, and no duplicate entries. This ensures data integrity, making it easier to analyze trends and build accurate predictive models. These changes were made to enhance the quality of the insights we can extract from this data later on, ensuring that any decisions based on this data are reliable and well informed.
Okay. The first one. This histogram shows the distribution of people with diabetes risk and no diabetes risk across the different age groups, helping to analyze whether age is a key factor in diabetes, so we can say the conclusion. And the second, it's gender and diabetes risk. So this chart shows the percentage of diabetes risk is positive and negative for males and females, making it easier to compare the risk between the different gender. And the third is this, so we can say this graph shows the distribution of different symptoms in people at high and no risk of diabetes. If certain symptoms such as genital thrush and alopecia have a similar ratio of red to blue, they may not be a major risk indicator for diabetes. If some symptoms are most entirely red in the high-risk group but rare in the low-risk group, it may be a highly sensitive feature of diabetes. With the coherence relationship between it, the heat map shows correlations between different symptoms and helps determine which symptoms often occur. So as you can see, red near number 1 indicates high correlation, indicates that these two symptoms often occur together. Same as blue near to 1 indicates a negative correlation, which shows that two symptoms rarely occurs at the same time. And lastly, close to 0 indicates no significant relationships. Next one. Association and age and number of symptoms. If a higher number of symptoms is associated with diabetes risk, i.e. red dots scattered at high symptom values, then the number of symptoms is a key factor in diabetes risk. The scatter chart shows how many diabetes symptoms people in different age groups have, and distinguish them based on diabetes risk, i.e. red for higher risk and blue for no risk. If all the people show more symptoms, mostly in the red group, it indicates that age and the number of symptoms together increases the risk. However, if young people also have a higher number of symptoms and diabetes risk, this suggests that lifestyle factors and genetic factors may be included. While older individuals tend to show more symptoms, age alone does not fully determine the risk of a person having diabetes at early stage.
Okay, so generally for our presentation, we try to find out if the risk of diabetes was related to age, gender, early symptoms through data processing and categorization. In the stage of data processing, we standardize the data format, reduce dataset. Besides, we also reduce some duplicated rows to ensure the data visualized sufficiently. After visualizing the data, we create 5 graphs that show the relationship between age, gender, symptom, and diabetes risks, as well as the co-occurrence frequency of different symptoms of diabetes, and the relationship between the age and the number of diabetes symptoms. After analyzing the data, we found that the risk of diabetes increased with age in people who are under 14 years old of age, but decreased slightly with age in people over 14 years of years old. So we believe that age is not an accurate predictor of diabetes risk. For young patients at high diabetes risk, lifestyle, diet, and genetics are also the factors that consider their risk of diabetes. Gender analysis shows that men are more likely to develop diabetes than women. Therefore, we hypothesize that the difference in hormone level between men and women may also contribute to an increased risk of diabetes. In addition, the diagram of diabetes risk versus symptoms shows that diabetes risk is closely related to a variety of symptoms such as polyuria and polydyspnea, or sudden weight loss. Some symptoms like insulin delay healing and alopecia are also associated with the risk of diabetes. At the same time, we find the polyuria and polydyspnea show a highly correlation in diabetes risk detection. If patients have symptoms of polyuria and polydyspnea at the same time, the risk of diabetes was greatly increased. Finally, the graph also shows the relationship between the age and the number of diabetes symptoms, showing that the probability of developing multiple diabetes symptoms increases with age, and the risk will also increase. So that's all our presentation. Thanks for watching.